Good evening, class. We are looking at practice test number 4, covering chapters 7 and 8. Here's chapter 7, systems of linear and nonlinear equations, part 2. Solve the systems. Now, this is a nonlinear system. 3x squared minus y squared equals 12, x squared plus y squared equals 16. We basically go with one of the methodologies that we learned before. In this case, addition will do the job, because if you add them up, these two cancel each other. So x squared and 3x squared is 4x squared, 16 and 12 is 28. We're going to divide by 4. X squared becomes 7, and therefore x is plus minus square root of 7. Now we put that in one of the equations, for example, equation number 2. And because it's x squared, positive and negative result in the same thing. In other words, this is 7, and then move it to the other side, subtract it, and you get 9. Y squared equals 9, therefore y is plus minus 3. Now you have 4 answers. Combination of these two gives you 4 answers. Here's the answers. Negative square root of 7, negative 3. Negative square root of 7, positive 3. Positive square root of 7, negative 3. Positive square root of 7, positive 3. And we're going to check, and we are going to check with equation number 1, because we grabbed this from equation number 2. So I'm going to try one of it, and then you can try the rest of them. You really have to check. For example, if we go with the first one, 3 times minus square root of 7 quantity squared minus negative 3 quantity squared. So this becomes 7. This becomes 9. So 3 times 7 minus 9. 21 minus 9 is 12. Yes, it checks. This is 21, everybody. This is 20. Minus 9 is 12. And therefore, we showed the first one works, and the rest of them we should check in the same manner. Graph the system of inequalities. Let's see how we do that, everybody. First and foremost, we change each one to an equality, and we know how to graph equalities. Now let's look at the first one. We need 2 pairs. If x is 0, y becomes negative 2. If y is 0, x becomes 1. So I'm assuming very fast we can find that. If x is 0, y becomes 3. If y is 0, x becomes 2. So we have those pairs. We can graph it. Okay. So 0, negative 2. So it's here. 1, 0 is here. Connect them, and it becomes the first one. 0, 3 is up here. 2, 0 is here. Connect them, and it becomes this one. Now, we go back to the original inequalities. This is the less than, and therefore this line is a dashed line. This is greater than or equal, therefore it's a solid line. So if it has the equality, it must become a solid line. Otherwise, it's dashed line. So let's put the equations next to them. This is 2x minus y equals 2. This is 3x plus 2y equals 6. And now we need to pick up a test point. Now, if 0, 0, the origin doesn't belong to them, that would be the best choice. Now, do you have to go with 0, 0? No, you have to pick a point that doesn't belong to the line. And you can do it for each line. They don't even have to be the same point. But 0, 0 will do the job. So 0, 0 is here. These are the two inequalities. Now the checking takes place with the original inequalities. So this one, if I replace the x with 0 and y with 0, I get 0 less than 2. That's a true statement. And that means for the red line, 0, 0 works. So everything on this side. In fact, let's just try this with the red. So assuming we didn't have the blue line, we would shade that side, we would be done. Let's try it with the second one. If I put 0, 0 here, 0, 3 times 0 plus 2 times 0, 0 larger than or equal to 6 is a false statement. Therefore, for the blue line, this 0, 0 doesn't work. That means this side is not the answer, it's the opposite side. This side. So as you can see, the two lines give us 4 regions, 1, 2, 3, 4. Which one has both shaded regions in red and blue is right here. So this is the answer. Or we can see it here, red, blue, but the area of their intersection is the answer. So I hope everybody's clear on that. All right, for a graph this equality, y larger than x squared plus 2, it works the same manner. You have to go with the equality first, and y equals x squared plus 1. As you know, y equals x squared is a parabola at 0, 0, plus 1 goes up, and the point of intersection, of course, y-intercept would be 0, 1. So it looks like that. Again, this one is 0, 1, everybody, okay? Just in case. Now you pick a point, and by the way, this eventually becomes shaded because we don't have the equality. But for now, we pick a test point. What do you pick? You can pick 0, 0 or 0 to something outside the figure or inside the figure. Doesn't matter. For example, if you go with 0, 2, I'm going to replace the y with 0, x with the y with 2, x with 0, and I get 2 larger than 0 plus 1, and that's a true statement. Therefore, it's the inside. If you go with 0, 0, just for the sake of argument class, if you go with 0, 0, 0 equals 0, I'm sorry, larger than 0 plus 1, that's a false statement, okay? So that means 0, 0 is not included. Therefore, the answer is everything inside, and this is dashed because we don't have the equality. So it looks like that. A chemistry lab assistant wants to prepare 10 liters of 48% acid solution. In stock, he's got 80% and 40% acid solutions. How many liters of each in stock solution should he mix to prepare a 10-liter mixture? This is a class of problem known as a mixture problem. We have solved questions like this now in the form of a system. We're going to go. So you have to set up a table like this. The solution is 80%, 40%. Here's the mixture, the strength, volume, pure amount, or the actual amount of whatever, in this case, acid, okay? So we just put the numbers that we have here. So we have the 80% solution, we're going to say 0.8, and 40% solution, we're going to say 0.4, or you can keep it as a percentage, it doesn't matter, okay? And we want to get a mixture for the 8%, or 0.48. That would be the type of solution. So we want to get 10 liters of 48%. That means this is 10. How many liters of each? We have no idea. We're going to say X and Y, for example. Let X represent the 80% solution. Let Y represent the volume of the 40% solution. In which case, if something is 80%, that means the pure amount is 0.8 times X. If something is 40% solution, that means the pure actual amount is 0.4 times Y. And of course, the result, 0.48 times 10, or 4.8. Now, here's the two equations. This is one of them, X plus Y is 10, right? The volume. These two are mixing. We are adding up. Their total volume is fixed. And so is this one. 0.8x plus 0.4y is 0.48 times 10, or 4.8. So those are the two equations. You can solve it by any method you like. The idea is that to set it up properly. So having said that, we can go by the substitution by replacing the y with 10 minus x. So in other words, move the x and replace the y with 10 minus x. So we have 0.8x plus 0.4 times 10 minus x. And of course, we have already said the answer is 4.8 here. So 0.8x, and we distribute, we get 4 minus 0.4x. By the way, 1 decimal, 1 0, they cancel each other. So we have these two add up to 0.4x, subtract the 4, and we get 0.8. Divide by 0.4, and x becomes 2. If x is 2, that means 2 liters. Y must be 10 minus that, 8 liters. So we have 2 liters of 80% and 8 liters of 40%. And all you have to do, multiply these two, it must add up to 4.8 because you want to check. And it does. If you multiply these two, you get 1.6, 3.2, they add up to 4.8. So you have to check, everybody. Similar questions. How many liters of, again, a mixture problem. How many liters of a solution that contains 15% chemicals must be mixed with 6 liters of solution containing 10% chemicals to make a solution containing 12% chemicals? So let's go with the same type of table. The solution is 15%, the 0.15, 10%, and the mixture, okay? And so this is 0.15. This is 0.1. And we have 6 liters of 0.1. So this is 0.15. This is 6 liters of 0.1, or 10%. When we mix them, we get a 12%. And by the way, this must always be in between, because you're mixing these two. You can't get a result larger than this or smaller than this. Must be in between. So how many liters of 15%? I don't know. How about X amount? Then what would be the total volume? The sum of these two, X plus 6. So the product of these two is the pure amount of chemical, whatever chemical it might be. So the product of these two is 0.15x. The product of these two is 0.1 times 6 or 0.6. And the product of these two 0.12 times x plus 6. And this is the equation. Add this one and this one to get this one. 0.15x plus 0.1 times 6 equals 0.12 times x plus 6. That should be the equation. And now this, okay, this is 0.15x. This is 0.6. Distribute 0.12x and 0.72. We're going to move things around. We're going to subtract 0.12x and we get 0.03x. We're going to subtract 0.6 and we get 0.12. And divide and we get 4. That means 4 liters of 15% solution. Systems of equations. A plane can travel 800 miles per hour with the wind and 720 miles per hour against the wind. Find the speed of the wind and the speed of the plane in still air, set up a system of equations and so on. It's important to understand when we go with the in the same direction as the wind, or if we are swimming as the current, the speed of the wind, the speed of the current in the same direction will help us, will be added to our speed. And if you're going against the wind, against the current, it works against us. So first and foremost, I'm going to go with the initials. I'm going to let P represent the speed of the plane and W the speed of the wind. You can go with X, Y, Z, anything you want. So having said that, a plane can travel 800 miles per hour with the wind. So that means P plus W is 800. And against it, that means P minus W is 720. And it's important to know P is obviously larger than the wind. So P minus W. Obviously, when we add them up, these two cancel each other. This is 2P. This is 1520. Divide by 2 and you get 760 miles per hour. If P 760 plus what number is 800 is 40 miles per hour. You can put it into the second one. Either one gives you the speed of 40 miles per hour. Very, again, straightforward. Admission tickets to a Little League All-Star game cost $4 for adults and $1.50 for children. A total of 225 tickets were sold and a total of $500 was collected from ticket sales. How many adult tickets and how many children tickets were sold? Set up a system. And again, in essence, you have the same concept, a mixture problem. So the setup is very simple. Adults, children, total tickets price for each one, number, total amount, and so forth. So let's go one by one. From the get-go, $4 is the tickets cost and $1.50. So $4 for adults, $1.50 for children. That's the first thing. Then a total of 225 tickets. So the total for number would be 225 tickets were sold. And how much? $500 in total. Total amount, $500 was collected. So that's the given. I hope everybody can see what happens here. Okay. Now, how many adults, how many children? You can go with X and Y. I'm going to go with the initials. It's easier to remember A and C. Obviously, A represents the number of adults. C represents the children. So that's one way to do it, to remember what you picked. Okay, although the table is telling the reader what A represents, or X for that matter. So how much do we collect from adults? For A, from children, 1.5 C. For A, 1.5. So this is the first equation, A plus C is 225. This is the second one, total amount for A and 1.5 C must be 500. And that's it. So with the help of this table, we could easily set up the system. You can do whatever you want. You can do it by addition, by substitution. Either way is fine. So, for example, if I want to get rid of the A, I can multiply this one by -4. And this gives me minus 4A, minus 4C, minus 900. So I'm going to keep the second equation intact, and these two cancel each other. This is negative 2.5 C, negative 400. Okay. Negative cancels out the negative. I don't want to have a decimal in the denominator. We don't do that. Therefore, I'm going to change both of them by multiplying by 10, 4,000 over 25. I hope you know that 100 divided by 25 is 4. So 4 times 4 is 60. And so if 160, I mean, if C is 160, the rest of them, that means 225 minus 160, that means 65 must be for A or adults. And of course, it has to be checked with the second equation. Okay, everybody? I just used the first one. A plus C is 225. I highly recommend you do it. It takes a split second. It's not a big deal, everybody. One leg of a right triangle is 4 centimeters less than the other leg. The area of the triangle is 70 square centimeters. Determine the length of each leg, set up a system of equations, and solve. First, it's important to remember what we're discussing here. So we are looking at a right triangle, and the legs are missing X and Y. So one of them is X, one of them is Y, and the units centimeters, because the area, which is 1/2 base times the height, is 70 square centimeters. So that's just to get us started. Now we're going to go back and read. One leg of a right triangle is 4 centimeters less than the other. According to our drawing, X is less than Y. So X equals Y minus 1. X equals Y minus 1. Half of base times height. When you have a right triangle, the legs, one of them is the base, one of them is the height. Half of X times Y is 70. And as long as we can see this setup, it works out nice and easy. All right, first and foremost, let's get rid of the fraction. In this case, let's multiply by 2, and it becomes xy equals 140. And now replace the x with y minus 4. Clearly, substitution is in order. And so we get y squared minus 4y. We move this to the left so we can use the quadratic formula or factor. We want two numbers. The product is negative 140. The sum is negative 4. Those are actually not difficult. Negative 14 and positive 2. So y is either positive 14 or negative 10. Sides can't be negative. There's only one answer. Y equals 14. If y equals 14, x must be y, 14 minus 4, or 10 centimeters. And I hope you see we can easily verify with the second equation. 10 times 14, 140, times 1/2 is equal to the area, which is 70. So you can quickly check it out. The sum of three numbers is 105. The third is 11 less than 10 times the second. Twice the first is 7 more than 3 times the second. Find the numbers. First and foremost, define your variables. Which one is the first one? Which one is the second one? Which one is the third one? Let's go with X, Y, Z, or anything you like. That's the first step. Define your variables. So we're going to say the first one is X, the second one is Y, and the third one is Z. If the sum is 105, X plus Y plus Z is 105. So that's our first equation. Now let's move on to the second. The third is Z is equal to, the third is 11 less than 10 times the second. Which one is the second? Y. 11 less than 10 times the second. What is 10 times the second? 10y. What is 11 less than that? 10y minus 11. So Z is 10y minus 11. Twice the first. The X is the first one. Twice the first. 2X. Twice the first. Is 7 more. Is 7 plus. More than 3 times the second. Is the second 3 times y. So 2X is 7 plus 3y. So each sentence gives us an equation, and now find the numbers. So I hope you see how we did the translation here, everybody. And again, to speed up the process, let's put a number here, equation number 1, equation number 2, equation number 3, so we can go back and forth. Now notice, Z is given. So obviously, the best course of action is to, and this one doesn't have a Z, to replace the C here, the substitute the Z here with 10y minus 11 and make equation number 1, getting rid of the Z. So X plus Y, and we're going to replace the Z with 10y minus 11 is 105. And now we're going to call this equation number 4 by combining the following. So X plus 11y equals 160. So we move the negative 11 to the other side. So now, equation number 4 is what we just came up with. Equation number 3 is already there. We just write it without any change. Now, bear in mind, you can do anything you want. So I'm going to show you a very fast way to handle this. Instead of solving for X here, and you can, or for X here, and you can, see 2X is 7 plus 3y. So if I multiply this one by 2, then I can replace the 2X with 7 plus 3y. So I'm going to multiply this one by 2, and it becomes 2X plus 22y equals 232, right? So 2X, 7 plus 3y. Remember, when you're solving, as long as you are consistent, any method you choose will do the job, and that's fine. Now, I'm going to replace the 2X with 7 plus 3y. When we do that, these two give us 25y. And we move the 7, we get 225. Divide both sides by 25, and y becomes 9. So if y is 9, look, equation number 2 will help us find z. 10y, that means 10 times 9, minus 11, that's 79. So we got Y as well as Z. Now we can go with the first one. They add up to 105. This is 9. This is 79. That means 88. Subtract from 105. X becomes 17. And we write 17, comma 9, comma 79. Now bear in mind, we used equation 2. We used equation 1. All you have to do, check with equation 3. 2 times x is 7. 2 times x is that 2 times 17, 34. 7 plus 3 times 9, 27. And that's right. So it just takes a second to check, and it's really not a big deal. Now, I'm going to continue with the same question. We already have those, and we already have the answer, and we decided the first one is X, the second one is Y or Z. And what I want to look at, in this case, I want to go with the augmented matrix, write it down and follow matrices, just for the sake of argument, so you see how that works. First of all, what is the augmented matrix? You have to rewrite this. How? The first equation is fine. The second one, you move the negative 10y here. And this one, you move the 3y here. That's the first thing. Now, it might be easier to go on with the column or rows. I'm going to do both ways. If you go with the row, you put 1, 1, 1, 105. This one, there is no x. 0, negative 10, 1, minus 11. This one, 2, minus 3, there is no z, 0, 7. If you go with the column, x would be 1, this one is 0, this one is 2. Y would be 1, negative 10, minus 3. Z would be 1, 1, I don't see anything, 0, and this is obviously the constant of the solution. So write the augmented matrix, and now you can do the matrices by many methods. Okay, you can do the row transformation, you can do the Cramer's rule. So I'm going to use a calculator, okay, just to show you. And we are going to put this in here, and we're going to do RREF. And RREF, if you look at the last column, that's exactly what we have here. So just I wanted to show you that we can go by that method as well. Let me look at one more example that we have time now. Jay borrows $25,000 to pay for a remodeling. In essence, this is also a mixture problem. He borrows some of the money at a bank that charges 8% interest. At the second one, he borrows 2,000, more than one half the amount borrowed from the first bank. The interest rate at the second is 10%. The balance of the $25,000 is borrowed from a third bank where 9% interest is to be paid. The total annual interest Jay pays for the 3 loans is $2,220. How much does he borrow at each rate? So first and foremost, banks, rate, amount borrowed, and I hope you see that the simple interest I equals PRT. So we're going to say number 1, 8%, number 2, 10%, number 3, 9%. So that's the first thing we do. Okay. Now, amount borrowed, we have total of 25,000. And let's just take care of this one since we are at the total. The total amount of interest, $2,220. So it says at the second bank, he borrowed $2,000 more than one half the amount borrowed from the first bank. So how much was from the first bank? Who knows? How about X amount? How about the second one? Who knows? Y. How about the last one? Z. And then we're going to make up equations because I want to go with the system of equations. So I equals PRT, the product of these two times T, and T is 1. Okay. Y is that? Annual interest means T is 1. We're talking about 1 year. So we pay 0.08 X here, 0.1 Y here, 0.09 Z here. So let's write the equations. Obviously, the first equation, X and Y and Z, they add up to 25,000. Now, at the second bank, he borrows 2,000 more than one half the amount borrowed from the first bank. At the second bank, Y equals, at the second bank, Y equals 2,000 more, 2,000 plus, then one half the amount of 2,000 plus one half X. So one half X plus 2,000 or 2,000 plus one half X, it makes no difference. And of course, this is the last equation, 0.08x, 0.1 y, 0.09z is 22 total. And that's it. We have the system. Practically, we are done, and we can take care of the business. Okay. Some of the things that we want to do first is to get rid of fractions, decimals, and so forth. So this one has a fraction. To get rid of it, let's multiply it by 2. If I multiply by 2, this becomes 2y, this becomes x, this becomes 4,000. This one, to get rid of the decimal, let's multiply by 100. So that means this is 8x plus 10y plus 9z, and this one add 2 zeros. And the reason we are doing that, it's easier to deal with now. So we are going to continue. So I'm going to go to the next one, and I'm going to call it equation number 1, 2, and 3. And this is from the previous page, everybody. Notice equation number 2 doesn't have a z, okay? So we use equations 1 and 3 to get rid of the z. So if I multiply, since this one has 9z, if I multiply this by -9, I get -9z, I can cancel it. So use equations 1 and 3 to eliminate z. And we're going to use the first one and multiply it by -9. So minus 9x, minus 9y, minus 9z, product of these two, minus 225,000. And just write the third one. So these two cancel each other. These two cancel each other. This is negative x, this is positive y, this is negative 3,000. And so now we're going to call this equation number 4, and we're going to put 2 and 4 next to each other. Both of them have only x and y. By the way, at this level, you can say, okay, instead of having to multiply one of them by -1, you can say, instead of adding, you can say, we're going to subtract one equation from the other. That works the same way, but either way. Let's multiply this one by negative. So we get x minus 2y minus 4,000. And so these two cancel each other. These two give us negative y, negative 7,000, and y becomes positive 7,000. So $7,000 is y. Equation number 2, minus x plus 2y equals 4,000 can be used to find the x. This is, of course, 14,000. Move it, make it negative from 4 becomes negative 10,000. Therefore, X is positive 10,000. Now we can go with, obviously, the easiest one would be equation number 1, X plus Y plus Z equals 25,000. So we have 10,000 and 7,000 and Z, they must add up to 25,000. If these two are 17, then Z must be 8,000, which means J bar was 10,000 at 8%, 7,000 at 10%, 8,000 at 9%. Okay, that's the meaning of it, everybody. Now, we just quickly can go with the augmented matrix and use a calculator. So if I want to go with the augmented matrix, and if I want to go with the row 1, 1, 1, 25,000 minus 1, 2, there is no Z, 0, 4,000, 8, 10, 9, 222,000. So 1, 1, 1, 25,000, negative 1, 2, 0, 4,000, and the last one, 8, 10, 9, 220,000. If you do RREF, you get, look at the last column. 10,000, 7,000, 8,000, and that's the same answer we got when we did it by hand.